Well, here we go. Good afternoon,
I
Jan.
think, yeah, I think I will have to find out the structure of these specifications.
Hmm.
Let me show you. Let me
All
show
right.
you.
Let's see what we got.
So it's that one. Wait, I'll put it there.
Okay.
That's easier for me. You,
I can see
yeah,
it.
why is it? Yeah, but now he's putting zoom on in front of it. That's not really handy for me.
Hmm. Okay, yeah.
Never mind. I put it back on the other screen. Then I look sideways, but
Oh, yeah, that's fine.
um, look. So yeah, I just cleaned up a little bit there, and I was quite enthusiastic, almost there. That was where we left last time. So to summarize, we had the link query where we had everything on the same level, so clients and yard names.
Mm-hmm.
We had all the clients, even the clients which did not have a yard.
Yep.
For example, here we have client D.
Mm-hmm.
You see, client D has no yard. What we didn't have were the yards that have no client.
Right, yes.
And because Jinaga needs to be able to do inverses,
Mm-hmm.
we cannot have anything else but inner joins. So no way to do that directly in a Jinaga specification.
Correct, yes.
So the purpose is to make a second specification to get all the yards which have no client.
Mm-hmm.
And even there, um, look, if, okay, let's Control K C.
Mm-hmm.
So yeah, perhaps all this, wait, I'm gonna delete all this rubbish here
Okay.
because otherwise we are not gonna see anything. And even that one, let's delete it. So here we have the Jinaga specification. There we do the query with that specification, and then we show
Mm-hmm.
the content.
Yes. Yeah, I'm
If we,
seeing.
I just commented this, and then it was supposed to work. But I forgot
Yeah.
something here. But yeah, this one.
I'm thinking, yeah, there's
Uh,
an unbalanced. Okay, that's it. Yeah. Mm-hmm.
yeah. So if I run this,
Okay.
that
You
works.
get all the yards. Yep.
I get all my yards. So I have A1, B1, B2, B3C, and yard X. So
Yep.
that's correct.
Yep. But what we want
Um,
is just yard X. We just want the ones that don't have a supplier or a client, so that then
yeah.
when we union, we don't get any duplicate yards.
So that's why I said,
Uh huh.
let's start with this one, where there are no facts of type yard clients,
Yeah.
such that yard client dot yard is yard.
Mm-hmm.
I think before, if I make, if I said this, then that works.
Really? Hmm.
No, no,
Yeah.
it doesn't.
yeah. Yeah. You're
Why?
not in the scope of a fact, so this wouldn't refer to anything here.
Oh, that didn't work, and then I
Yeah.
changed it. But why is this not working when? Because I tried to point to this.
Yeah. So that should be yard. Yeah, this would only be correct if you were doing this inside of a property, so that like you were creating a relation, so that you could encapsulate it. Um,
Oh, Or is this pointing to yard client?
That should be. Oh no, yeah. This in this context isn't pointing to anything. Um, yeah,
Because I,
there's. It's not wrapped inside uh, of a class. Well, I guess technically it is pointed to something, but because C# doesn't allow just free. Uh, well, I guess top level statements now allow you to have top level statements, but there is no this in a top level statement. Notebooks are not using top level statements. They're kind of cheating. So this does refer to something. It refers to that cheat class that notebooks created. But yeah, that's not what you want. Um, you want yard, and then I think the parentheses are the thing that that closed parentheses that it's commented out now. Um, that is one thing that
wait,
is,
I have here.
and you need a double equal. Yeah, so yeah, here you've got the assignment, so change that to that, and now we should.
There, so there I got it again.
Yeah.
All these things who keep me for hours. So here I should have yard X.
Yeah.
So that's correct.
Yes. And then
Now,
here you were going the next step.
yeah, because imagine that yard X would be deleted.
Mm-hmm.
Then I have to add this. So perhaps this is working now. No, it gets into red again. Oh, no, this one is on that level. Huh?
Yeah, so you were looking for yard client records that have not yet been deleted. So the yard client is that association between the yard and the client. So if you delete that association, you don't want it to count. So we're the. Okay, I think it's the assignment again.
It's not true.
Yeah, and you still get the same behavior because there aren't any deleted yard clients in this
I think I'm
test
going to
set.
put a very big poster here on front. I don't know why, but every time again, that's the same problem. Okay.
Yeah.
But then we are not there yet. So these are all the facts that I need.
Mm-hmm.
But then I have trouble seeing what do we put inside the Jinaga specification and what do we put inside the link after the query.
Yeah. Yeah,
I
this is
think
a similar problem.
most effective would be to put everything as much as possible into the Jinaga specification.
Mm-hmm.
Because that keeps the initial collection as small as possible.
Yes, yeah, that. Yeah, I would agree with that. Yeah, it's similar to in Entity Framework where you there are some things that you that if you were to put them in the iQueryable, the query provider wouldn't know how to turn that into the underlying query language like SQL. For example, one of the things you can't do in an Entity Framework and can't do in Jinaga either is to have a function call inside of the iQueryable, unless that's a function call that actually takes the iQueryable and returns a new one, because then it technically would be outside of the iQueryable and it would just be participating in building it. But yeah, if you've got inside of your Lambda if you were to try to refactor that comparison there and turn that into a function, then the iQueryable, the query provider, wouldn't know how to call that function. It wouldn't be safe to do so. So that's the thing you can't do in Entity Framework or in Jinaga. So Entity Framework has a few other constraints, but they've at least this is the job of the query provider. the query provider's done as much as they can in order um, to let you write those specifications, to write those iQueryables. And it tries really hard to turn those into SQL. So it doesn't have too many edge cases, but you still run into them every once in a while. Jinaga, so I've not I've not put that much effort into making sure that everything that you write can be turned into a specification. In fact, I initially started thinking in the opposite direction, where I want you to write a specification, and it just so happened that link had the right syntax. So you're writing a specification, you're not writing an iQueryable, and then, the constraints on what you can put into a specification, as you pointed out, things like being able to compute the inverse, being able to turn a specification into a set of feeds. These are operations that are performed on the specification in addition to just executing it. So all that to say, the part that you would do outside versus inside is similar to making that same choice in Entity Framework, except you have to pull more things outside in Jinaga than you would in Entity Framework.
Okay. But then, for example, here, is it correct if I would leave this one out, the yard names, that I cannot, I have to put yard names inside, because if I would do this, then I only have the yard facts getting out, and I don't have yard name facts in my collection.
Right, yes, that is true.
So I have to, this one has to be here.
Yes.
Okay.
Yes. So
yeah,
and then what you're ultimately wanting to do is to union this set of these objects that have yard and yard names with the other set, and that other set has the same shape. So we are 1/3 of the way there.
Let's have a look here. We had client name, and we had yard name.
Yeah.
So.
Okay, so we have to. We're not that third of the way there yet. So we do have to get them into the same shape first.
Yeah. So here it's names. But
yeah. So okay. So you've run the query, and then you're doing the projection, and you're using first or default in order to pick one of the names. So
yeah, but could I do this inside of the Jinaga specification?
You cannot. So two things that Jinaga does not support: default if empty, and first or default. It also doesn't support single, first, singularly default. So
what was that last thing you said?
Single or default.
Yeah.
So yeah, there's the four methods that are all just the four quadrants of.
Okay. Let me add that here also. Wait, this one we didn't know. This has to be in a separate link query, as Jinaga does not support default if empty. Huh? He helps me.
That was nice.
First
or default.
Default.
And then there's first and single
First single, yeah.
And then single or default.
Single or default.
Yeah.
Okay.
Yeah, and I think
So
I put a
that's
document up
documented.
there.
But so we need all the elements to be able to get client name and yard name.
Mm-hmm.
And so if we look into the specification, we have the yard names, so that's good. And the client names in the union, in this half of the union, they will be empty.
Mm-hmm.
So what we can do is let me copy a little bit. So let's call it yard view model. Never mind.
Mm-hmm.
So from yard in yards, no, then here it is like this.
Yes. Yeah.
It's from this. So these are the yards. Select new. Yeah, let's delete this one here. In the correct place. Yeah, here it is still there. Okay. So what we need. We don't need that. We don't need this projection. We can simply put
Okay.
this one here, no?
Yeah. So we want to have the same. Yeah, we're ultimately trying to get the same shape.
Right. If we put it like that, and then the shape we had here, we first had a client name. Oh, but here I'm putting
Mm-hmm.
yard names. Wait, where am I? Here, yard name.
Mm-hmm.
And so here, client name equal null.
Yeah. Yeah.
And then I have a yard name here. And that
Mm-hmm.
yard name comes from, yeah, but this is
Right.
not, yeah, yard names, first of default. So that should
Yeah.
work.
Yeah. I think that's right.
Yeah. Let's see what this does.
Oh, I can't infer the type. Yeah. So go ahead and do a cast on that client name. This ultimately is not going to be a problem, but right now in this intermediate step, it's a problem. So let's say client name equals parentheses string null, so that it knows what type we're trying to initialize here.
String null.
Yeah.
This. Yeah, that
Okay.
worked.
Yeah. So we've got client name, yard name.
Is that the
Now
same?
the projection from the other one, I think is, well,
This is the same, huh?
yeah, it looks like it is the same. Yeah.
Yeah. So now we could do a union. union model equal to, we had the client view model, yeah, union.
Yeah, I think it would
But
just
that's not
be
going to
dot
work.
union. Yeah, I think the union keyword is just for while you're inside of a link query, but yeah, dot union. Then you should be able to pass the other one in.
What am I doing here? And then here the yard view model.
Yeah, now we can comment out that line 36 because it's
Okay, yeah, because that is not what we need.
mm-hmm.
And then we need to repeat
Yeah,
this one. It's union, it's not onion.
yeah, yeah, and we've got
It's a little bit blur with
yeah,
my eyes. It's a little bit blur. So.
and we've got a
But
missing semicolon that it's complaining about.
yeah, yeah.
Or a semicolon, not a comma.
That's semicolon.
And then I think we're going to run into a
Yeah.
type issue. Yeah.
Yes, yesterday I was working in VB6, and VB6 was all the time complaining about the semicolons that I put everywhere. Yeah.
Okay. All right. So now we have the type issue that we need to resolve. So what's your best guess? I mean, that is a terrible error message.
Is it that it doesn't things both of these are the same type? So perhaps we can cast both of them to the same type?
Yeah, they're each an anonymous type. They have the same shape, but they're different anonymous types because they were created in different statements.
Yeah.
So if you declare an actual type that has that shape, then you can use that type in both places.
And then here, okay. But that type is going to be needed in both.
Yep.
So I will have to put it in front of this one. Huh?
Mm-hmm. Yep.
Okay, so it should be like what? A client name. So the type should look like, wait, what am I gonna give it as a name? Client yard record and yard type equal, and then it is 2 strings, huh?
Yeah, but you're declaring a class. So yeah, go ahead and use the class keyword. Yeah, I'm wondering if you've mentally switched to VB. I don't remember if that's the VB syntax.
Wait, just like this? No.
Lowercase c.
I'm again completely.
Yeah, and now you can drop the equal, and you're declaring a class. Yeah.
And we have first we have a string for my my client name, and after that I have a string for my yard name. This one no, and this one is it? No, it's not semicolon.
Yep.
What am I doing?
Yeah, what you want to do is declare a couple of properties there. So do the parentheses get semicolon set after each of those two.
wait.
Yeah. Yeah. So yeah, instead of the comma, then it's open brace get, and
Oh,
yeah.
okay. Yet I don't. Do I need setters here?
Uh,
No.
Actually, yeah, you no, you don't. So yeah, there would be a semicolon there instead of a comma. Yeah, and we don't need a comma at the end. Uh,
At the end, yeah.
yeah. So that might be all that you need, but you might also need init. But let's find out.
So, and then
Yeah.
we can perhaps just here. No, I cannot do a
No,
cast here.
no, it's going to be when you select new. That's the point at which you're creating the um, the object. So yep, you just give the name right there.
Yeah. Have to put a name as type or just the
Nope,
type like this?
just like that. Yep.
Okay. And I have to do the same. Wait. Yeah, here.
Not there because that one has projection in it. The client yard type is the other one.
Oh, yeah, yeah, yeah. Put it here.
Yeah.
Okay. Why is it complaining here? I put my type
Oh, go ahead
this
and
one
run that. Yeah,
first.
it hasn't actually declared it.
Yeah.
Okay, so this is going to tell us if we need the init, and I think we do. If we see the error message, it probably, I see where the squiggles are, but if you scroll down, it'll probably tell you that,
Because I have here.
oh, that's true, yeah.
But still doesn't solve the problem.
Yeah, so scroll down and let's see what the error message is, and I think this is telling us that we need the init.
Inaccessible.
Oh, declare them as public, yeah. Yeah, they're private by default.
Oh, is it in public in front here or?
Yep, that is correct. Yeah, scroll up a little bit so that we can see, or scroll down a little bit so that we can see the error message that's showing up below the cell.
Okay.
There we go. All right, so that's what I was expecting to see. Yeah, the property cannot be assigned to, which means that you need to give it the init keyword so that it knows that you can assign to it during initialization. So right
And
after,
where do we put that one?
yeah, right after the get semicolon, do init semicolon.
And this one again. Run that one again. And
There
now
we go.
this works. And
Okay, and now the projection is getting in our way. But yeah, so we're making progress.
wait, this one is okay now.
Yeah. But now it's having trouble here because client view models is an anonymous type that contains projection that then contains client view models or client yard types. So if you go back up to that first cell, you'll see how we're looking at the results, doing a select mini.
How can I see that? So the problem now is that.
Yeah, the problem is in the cell above,
Yeah.
because the type.
Yeah, but so
Go ahead.
one of the two is not the same.
That's correct.
On the same level.
Right. Yes. Yeah. Client view models. Yeah. If you you can see inside of the IEnumerable, if you look in the error message, IEnumerable of anonymous type, iQueryable client yard type projection. So it's really that
Wait.
that collection of projections that we want.
Anonymous type, yeah. So that was this one. And
Yeah.
the other one is different.
Yeah, the other one is good. You'll see that that one is just a an iQueryable of, or actually it would be an immutable list of client yard type.
Wait, if we would do this.
Yeah, okay, this would be good. Yes.
And later we will
Yeah.
put this one there as well, but we can only have one at a time.
Yep.
So if we run this,
Mm-hmm.
what do we get? We get just a client name and a yard name.
Yep. So that's the shape we want. But now look at this one.
Yeah, I have to remove this one.
Yeah. Now look at that.
And here I get a different structure.
Yep. Yeah, projection, which then contains client name, yard name.
But this was already solved, no?
And look what you did here. Look at that select many on line 19. That's how you solved it.
Yeah, but so, okay, because we are using client view models, and we should be using the projection of that.
Yes.
Okay. So what we do, this one remove, this one uncomment. So client view models. So like this, it should work.
Yep. And now we have all of our yards.
Yeah. We have client D and we have yard X.
There it is.
Cannot save that.
Yeah. Okay, so yeah, I want to do a retrospective on that. I want to understand what would make that process go better. I don't know. I mean, I would love for this to be a Factual Studio thing, but I don't know if Factual Studio is the right place to solve this problem. So what are your thoughts?
I think because the last thing my last idea before we started the meeting was I really have to look more at this structure.
Mm-hmm.
As well on the level of the Jinaga queries.
Mm-hmm.
Wait, where were we here? So on the level of the Jinaga queries, as on the link afterwards, because it was there that I realized if I just put yard here, in my head, if I have the yard, I have everything, which is not true. I have the yard facts, but I don't have the name facts.
Right, right.
And I think by displaying the content and the structure and analyzing that every time, that I will get further.
Yeah. Now this is a challenge. If you didn't have polyglot notebooks, how would you solve this problem?
Without polyglot notebooks,
Yeah.
then it becomes a big problem because I cannot immediately see what is the result.
Mm-hmm.
Of course, in C# you could just make a small test and every time run it.
Mm-hmm.
But I think Polygon notebooks is really interesting to. It's easy to make additional facts.
Yeah. Yeah.
For example, now I would like to check if I delete the Yard client, if that works, I can just add another fact and I can check it,
Mm-hmm.
which I can do in C# as well. But I think it's more complicated. I don't know.
Yeah. Yeah. The reason I'm thinking down those lines is that the the tooling that I want to provide will, in some sense, take the place of polyglot notebooks. But this is a problem that I don't think my tooling is going to address. So you're back in code land. You've got your WPF app, your Maui app, your Blazor app, and you're just writing code. You might be writing tests, and then what can I provide in
But
addition?
the tooling will allow to make the specification.
Yeah.
So in fact, the whole process, what we do now in Notebook, will
Yeah.
just replace Notebook.
Yeah. So
Now,
it'll
one
help
of the
you.
things that was also not clear for me is what can be done in Jinaga and what cannot be done in Jinaga.
Yeah.
Um,
Yeah. For that, I did.
because I
Make a
saw on the
page.
Jinaga page there is also the select many, which I think you added recently.
Select many actually is necessary for a lot of the underlying patterns. Um, yeah, let me share. Where's the share button? Here's the share button. So, all right. So this page here on Jinaga.net, we've got the link guidance, and then there's limitations. So this was a set of pages that I put together because I was noticing that the LLM was having trouble creating link specifications. When I go to TypeScript and then come back, I sometimes forget how to create specifications. So it's like, okay, let's put together this guidance, and then the limitations. That was really really telling the LLM, don't do this, which is really hard for an LLM to do, to see a thing and not do it. But yeah, so first thing, you can't have conditions that are based on the fields. So like here we've got the term name. So offering term name equals term name. You can't say all the facts where this string is equal to this value. Or this number is greater than this value. Yeah, that's allowed in LINQ or in and in SQL, but not allowed in Jinaga. So that will give you an exception.
What's the difference there with what we did just now?
Yeah, so this isn't one that we ran into now. So
no, but if we go to the specification that we wrote just now, for example, we say yard clients.yard equal to yard. Share it again here.
Okay. Yeah, I was looking for it. Hey, it disappeared.
You see it?
Yes.
So for example, here or
Yeah.
here, what is the difference with what you
Okay.
showed
Yes.
just now?
So the difference is invisible because it's types, and the types aren't explicit here; they're inferred. So supplier, first of all, is the fact that's declared in the given. So that's of type supplier, capital S. And then yard is something you've
Here,
declared here from yard in facts of type yard. So
yeah,
that's also a fact. And its type is yard, capital Y. So so yeah, comparing facts is supported because that's doing a query based on the structure of the graph. In this example, term name is not a fact; it's a string.
yeah. Can you share the example again?
Yes, I think.
I stopped sharing here. Yeah.
Yeah, yeah. I think I'm still
Um,
sharing.
yeah. Now I
Okay.
can see it.
Yeah. So yeah, term name comes from the match, but notice here I did a given school string. So
Okay.
that's not a fact type.
Yeah.
That's a value, and so you cannot um, you cannot do any kind of filter based on the a value like that. It has to be a fact.
Okay.
And so here's the alternative. So we did a we first create a term that has the value that we're looking for, and now that gives you the identity of the fact because that's the only thing in that fact is the school and the term name. So that means now this is a unique fact. And
Yeah.
so now you can write that specification in terms of the term, and now it's just based on structure.
Okay. Yeah.
So that's not one that we ran into, but that's one of the first things that certainly the LLM runs into, and I think a lot of people will run into that too. But then these are other things that are not supported in the specification language, so you can't use these inside your LINQ query. So first or default, singular default does not support those. And the reason is that Jinaga specifications are always collections. In fact, they are always sets. So they are unordered collections. And these all, the
Goes
first
an
pair,
order.
yeah, they depend upon an order. Which one's first? Yeah, now single or singular default, maybe I could figure out a way to support those because they still work on sets, but but the specification can't guarantee that a set has only one element in it. So even if I did figure out how to make that work, it would almost always be a bug because there's no way to constrain it, and then as soon as you get a a simultaneous edit, then your single throws an exception. And yep, so that's those are not in the spirit of what we're trying to accomplish. Then group by, this one starts to aggregate over the collection, and for inverses to work, it really just has to be this is the set that I'm looking for, so that I know this inverse is going to affect that set. The group by would then do an aggregate over that set. So while I might be able to make it work, I would make it work by basically taking it out of the specification and then actually doing that in the second pass. So
Making it a separate link expression.
yeah,
Okay.
yeah. So I basically just left that up to the application developer. You make it a separate link expression. Um,
Mm.
yep. So in addition to um, yeah, and like order by is similar in that we're talking about sets, and we can't do any kind of operations based on the field values. So those two things taken together, you can't do the order by. Um, so yeah, a lot of times, like in the example that we were just looking at, we are thinking about query. So await query, and we get back our results, and now we can operate on that collection. But that's not the way that you usually use a specification in an application. Um, you will usually use the observer. So let's go all the way up to the top.
Which
So
automatically updates.
yeah. So yeah. So yeah, query is good for doing the um, kind of the one shot. Give me the results.
Mm.
But yeah, watch, getting
Watch.
back an observer is what you will usually do. And then now you've got this action that you perform whenever something is added. And so if there is any aggregation to be done, then you have to do that. You have to somehow keep state here inside of this added action. So okay, that's the group that I want to add that result to, or this
Mm.
is the sum that I want to increment. So any kind of aggregate, it requires this to
Because
be stateful.
because in our concrete situation now, we have a union of two specifications.
Mm-hmm.
So if we have a watch on both specifications, yeah, we still have to do that union.
Yeah, and the way that you would do that with the watch is that you would take your let's see, yeah, no, you would take your results that you're getting from the union and instead declare that as an observable collection, and then both of these actions would add to that observable collection. So they would both
Okay.
create that same data type that you defined,
Mm.
um, but then you would add to it from two different places.
Okay. So,
So it still ends up doing a union. It just does it in a more imperative
mm,
way rather than declarative.
yeah. If it's a union, it's just adding.
Mm-hmm.
Um, if it would be something else where they interact, because now it's just adding, so it doesn't matter which sequence you have.
Mm-hmm.
But I can imagine subtraction, for example. Yeah,
Mm-hmm.
you have one set and you subtract the second set.
Yeah.
Um,
Yeah. I think. Yeah. So what you would. Yeah. You'd have to come up with the what's the specific use case we're talking about, but I think what you would end up with is that you would first try to do that subtraction in the specification, so using a where not exists. But yeah, if it was I want to subtract all of all of the customers who have spent less than $1,000. So now it's based on a field, and you can't do that in a where not exists kind of thing. So so yeah, now I think what you would end up with is, well, in that case, you could do that as a where clause after the fact. So,
yeah.
and then in the action, that would become an if. So, yeah, that would short circuit and filter those out. But yeah, if you really wanted to do a difference, so you've got two sets and you want to subtract one set from the other, then yeah, I think you would have to. I think what you would have to do is inside your actions actually construct those two separate sets, because you don't know which action is going to happen first. That's the challenge. And then you would have some additional processing that subtracted the two. You know what? This might be a good use for. It is the extensions.net. What? Yeah, .NET Reactive. There we go. This might be the way to accomplish that. So with this library, you can construct those observable collections, but it's not like the MVVM type of observable collections. These these are observable by these functional. Show me some code. Yeah, functional. Oh, well, it just took me back here. Okay, that's fine. There we go. We got some code. All right. So with this one, trades is an observable collection. So then you can write this specification. Well, I don't want to use the word specification because I don't want to confuse that with a Jinaga specification. But you write this link query, and that produces another observable collection, but one that you don't yourself put stuff into. With trades, you can just add a trade to that collection. But when you do, it's going to run this this filter, and then it will optionally add that to big trades. So that's all happening in memory. In fact, this might be just regular link, and then this is. Yeah. I really should have some. I mean, one to complain here, but some better example code. I want to be able to just see some code, point to it, and say, there's the point. But the upshot is that if I created an adapter from watch to reactive extensions, then you could write the union code in reactive extensions and get the behavior that you want. That might be the way to go. Now, of course, this has its own learning curve.
Yeah. Because if we add more packages, it becomes even more complicated.
Yeah. Yeah, I wouldn't want to have Jinaga take a direct dependency upon this. Instead, I would have an adapter package that depends upon both of them, and basically turns the watch. So it would have an extension method on Jinaga client that would then call watch, take the observer. Well, actually, it would call watch and pass in an action that updates an observable collection, and then gives you back that observable collection. You still have to manage the observer. You'd have to be able to start and stop it. There might be a way to wrap that up into this.
Now, perhaps what could help for all these type of problems is to document, like for example now with this notebook, I try for myself to document a little bit why we do it, why don't we do it, what does work, what does not work. And by the time TWS is working, perhaps we have so many examples with the reasons why and why not, that it might be helpful to study that.
Yeah, I think so.
So that somebody who says I need to make a specification, okay, what I need is like that.
Yeah.
Same if you say, okay, I have to do a union. Here is an example. Makes it easier.
Yeah, I like that. That's derived from real world patterns and scenarios. Yeah.
The question there is, are the examples not too complicated? But if you want to run into trouble, you need a certain level of complication. Otherwise, if you stay with very small specifications, you will not run into troubles.
Yeah, that's true. Yeah, that is always the challenge of coming up with teaching material. Yeah, like you go to some Udemy courses, and it's we're going to build this whole thing, and it's this really complicated thing, and so you run into all the different problems. But it's a 17-hour course, and if you want to just answer one question, how do I pull a record from Entity Framework and include the child records? But I have to skip to hour 50
next week
or 5. And yeah.
If you have to follow the 17-hour course.
Yeah, so balancing that with getting into trouble with a real example, that is a challenge. Okay, so yeah, tooling not sufficient. Education is also a part of that.
Thing is to have somebody I can ask if I run into trouble.
Yeah.
I think that's also one of the important things. Once people start using the framework, that they have a place where they can ask, and it would be good if it would be a place like this where all the people can hear at the same moment, see the problems and the solutions.
Yeah. That would be awesome. Yeah. So I'll definitely keep this going weekly, and maybe eventually people will start popping in here to just ask Jinaga questions. That'd be great. Meanwhile, there's also GitHub issues, and there's just posting on the Discord general. So so keep keep bumping into trouble and documenting it.
Not too much trouble, because I want to see some progress as well.
Yeah.
But okay, we got a specification ready now. That's step by step, but it's very little steps.
Yeah. Very good. All right.
I'm gonna let my eye rest a little bit now.
Yeah. Good call.
Screen is not doing good, but good, Michael. See you next Thursday.
Yes, indeed.
Okay.
Yeah.
Thank you very much.
All right. Thanks.
See you. Bye-bye.